Have you seen a question like this before? This is x raised to the power of x equal to 5 raised to the power of x plus 25. And we're asked to solve for the value of x. Now this is a strong Olympiad question, a very strong one, but I'm going to show you how you can do this in less than a minute. Now here's the solution to this problem. We have that x raised to the power of x is equal to 5 raised to the power of x plus 25. And then this is how we are going to do this. You know that by law of indices, if you have a raised to the power of b plus c, this is the same thing as a raised to the power of b multiplied by a raised to the power of c. Yes, because if the exponents are being added, it means that they are multiplying, the base are multiplying, and the base must be the same, because the multiplication law of indices states that if the base are the same, when you're multiplying, you can pick one of the base and add the exponent. So if you're adding the exponent is b and c. If you're adding it, you're going to add b plus c. So that is how this rule brings out this rule here. So since we have x plus 25, I'm not wrong to bring this as x raised to the power of x equal to 5 raised to the power of x multiplied by 5 raised to the power of 25, because when the bases are the same, we can add the exponent or the powers. Now I will divide through by 5 raised to the power of x. You know, in an equation, anything you do on the left hand side, make sure you do it on your right hand side. So I'll also divide here by 5 raised to the power of x, so that 5 raised to the power of x will cancel out. Now I'm left with x raised to the power of x divided by 5 raised to the power of x to be equal to, these are already out, what is left is 5 raised to the power of 25. Now let's observe this again. We have x raised to the power of x, we have 5 raised to the power of x. So by observation, we can see that the numerator has x as the power or x as the exponent, while the denominator also have x as the power also. So they have a common exponent or they have a common power. So what I will do is I'll group this as x all over 5. All of this is raised to the power of x, because by law of indices, if you have one power outside and then you have a function inside, everything in the bracket will take part, or everything in the bracket will share the exponent at the top. They will share this. So this is the same as x. This x will share this x. This 5 will share the x. So that is what happens here, to be equal to 5 raised to the power of what? 25. Remember, we are looking for the value of x. Now this is what we are going to do. We'll divide both exponents, both exponents by 5. Divide both exponents by 5. So if I do that, I'm going to have x all over 5 raised to the power of x divided by 5 to be equal to 5 raised to the power of what? 25 divided by 5, because I'm dividing both exponents by 5. Now what I have now is x raised to the power of x over 5 or raised to the power of x over 5 is equal to, now 25 divided by 5 is what? 5. So this is the same thing as 5 raised to the power of 5, because 25 divided by 5 is 5. Now let's observe. Observe now. The base is x over 5. The base is 5. The exponent is x over 5. The exponent is 5. So what can you call this? It means that the base x over 5 is 5 and the exponent x over 5 is still 5. So I will say by comparison, or by comparing both sides, by comparison we will see that x over 5 is equal to 5. Yes, because the base is equal to 5, the exponent is still equal to 5. Now remember, what I'm looking for is just the value of x. So if I cross multiply, once I cross multiply, x times 1 is x, 5 times 5 is 25. So the value of x that will satisfy this equation is equal to what? 25. Now we are not going to stop here. I'm going to show you how this is true. That means if x is equal to 25, I'm going to prove it and I'm going to show you how it is equal to 25. And remember, if it is equal to 25, that means that if I substitute this value into the original equation, the right hand side is going to be equal to the left hand side. And if it does not correspond, that means something is wrong somewhere. You get? So all you have to do is stay tuned to this video. Now we know that x is equal to 25. So what we are going to do is, we know the original equation is x raised to the power of x equal to 5 raised to the power of x plus 25. So let's prove. We know that x is equal to 25 by our solution, by our solving. So this will be 25 for this x raised to the power of 25 also equal to 5 raised to the power of x is what? 25 plus 25. Now this is something as 25 raised to the power of 25 to be equal to 5 raised to the power of 25 plus 25 is 50. Now 25 can be expressed in index form as 5 raised to the power of 2. That's for this first one. You know, 5 raised to the power of 2 means 5 times 5, which is something as 25 also. So 5 raised to the power of 2 for this 25 as the base will be raised to another 25 up. And all of this will be equal to 5 raised to the power of 50. Now this implies that, you know, this exponent can multiply the exponent outside the bracket. To multiply. So 2 times 25, let's bring down this base. So 2 times 25 will give us what? 50, which is equal to this one, 5 raised to the power of 50. So from this we can say that the right hand side is equal to the left hand side. So therefore, since the two equation is balanced, this shows that the actual solution to this Olympiad question is x raised to the power of the actual solution to this question is x equal to 25. Now if you find this video interesting, do not hesitate. Make sure you like this video, drop your comments, subscribe to this channel and share to 5. See you next time. Bye bye.